I'm going to present to you the Ventway Sparrow miniature turbine-driven ventilator made by Novitec. I'm going to give you an overview of the machine. I'm going to discuss the abbreviation used, which is standard terminology on ventilations. I'm going to discuss some limitations and conditions for use, and I'm going to show you the components that come when you buy a Ventway turbine ventilator. This machine is easily portable, designed for civilian use in emergency situations and also for military use in the field. It's suitable for first responders, on the side of the road, in an ambulance. It's lightweight but highly efficient as a ventilator. I don't know of any other ventilator with this capability as light as this in the world. It's suitable for non-invasive ventilation using a face mask, and it can be used for invasive ventilation with a laryngeal mask airway, an endotracheal tube, or a tracheostomy. You have the ability to switch between invasive and non-invasive, allowing leak and not allowing leak. The abbreviations we use in the user interface and in the manual are exactly the same ones that are used internationally on other ventilators, like breaths per minute, continuous positive airway pressure, liters per minute volume, non-invasive ventilation, peak end expiratory pressure, peak inspiratory pressure, and standard terminology of the type of ventilation like pressure support ventilation and the inspired time, expired tired volume, and inspired tidal volume. The graphic user interface on the front of the screen, which I'll show you when we switch it on just now, has icons which are very clear and easily understandable. To go back to the previous screen, to change to the next screen, to change the language, and I'll show you the languages options, to see graphs of pressure or flow, to confirm or cancel an input, to go back to the home menu to see the outline of what's available, to give a manual breath, and to access the main menu to make changes to the ventilator setting. I'm going to describe a few conditions of the use. The Ventway is intended for emergency use, out of hospital and in hospital, in adult and pediatric patients above 5 kilograms. It is a restricted medical device intended for use by qualified trained personnel, but under the guidance of a physician in terms of training and decision making on what to do. When you buy a Ventway ventilator, you receive the ventilator itself, which I have. You receive a manual of device documentation. You receive a battery pack, which is a disposable battery, and you can have additional ones. Each one gives you about 4 hours of ventilation, and you can change them. And if you're near a power source, you can plug into the back the electrical power cable and provide continuous use without a battery, and it will charge the battery. The front panel of the ventilator has got a control knob which you turn and click to enter the input. It has the graphic display, which I'll turn on shortly. It has a place to place the circuit in the patient circuit port and placing of sensing and control tubes. You will notice that this is designed extremely cleverly with a flat end and a round end at the top and a flat end. So there's no ways this can be placed in any other way but the correct way. Many ventilators have tubes and you have to identify where they're placed, and you can sometimes put them in the wrong place. It's impossible with this ventilator and this circuit to connect it incorrectly or place the tubes that are the sensor tubes and the expiratory valve tubes in the wrong place. The ports here are the pressure measurement port at the top, the flow measurement port at number 2, and these are the two that are at the sensor at the patient side of the circuit, the expiratory valve control, which controls also the PEEP, and the ventilator outlet flow. The rear panel shows you the items that exist and how to use them. First of all, there is the air oxygen inlet, where you will place, and I'll show you later, an oxygen supply or a valve which gives the oxygen from a high pressure supply. It has a place to plug the electrical power point in over here. It has a place to put a USB connector to download and upgrade the software or to download information to check it. It has a power on or off button, and it has a place for the battery and a battery lock. The battery, very simply, slides in only in one way into the position and is locked. When the power source is on, the battery will be charged if it has electrical power source, and the battery can be removed without losing the power. Click and pull it out, and you can place another battery in. So if you have batteries, enough batteries, you will be able to run this machine continuously without electrical power. And if you have a small bottle of oxygen with small flow, with this reservoir system, which I'll describe in another presentation, you can run the patient on oxygen without need of pressurized oxygen. The battery status is clearly identified on the graphic user interface. Note that there are two kinds of batteries. There's the non-rechargeable battery and the rechargeable battery. On the screen you will see that if the battery is not in place, but it's plugged into electrical power, you have an icon which indicates no battery and electrical power. Note that the non-rechargeable batteries are in white and the rechargeable ones are in blue. The non-rechargeable battery with no external power shows as the battery without the electrical connection. Similarly, if you plug it in and it's charging, you will see the non-rechargeable battery with the external power source connected. For the rechargeable batteries, it's the same. While it's charging, you see an electrical indication. You can see when it's plugged in. You can see when it's fully charged and there's no electrical source. And finally, if you plug it into electricity, you see the red indicator that it's plugged in, but it's not charging. So something in the connection is not working. The battery charge level is identified also by these icons on the graphic user interface, either full, medium energy level, low energy level, or critical. And there are alarms which tell you at which stage this battery charge level exists. Now, the additional items that you have to decide if you need for your ventilator is if you're going to use it in hospital, you need such a demand valve, which can give you oxygen concentrations from 21% to 100% via the wall socket of a hospital or emergency room. If you you're not in hospital, you don't have that, you use the low flow oxygen enrichment kit, which is an incredibly clever design. You have oxygen coming from a bottle to this. The reservoir holds the oxygen, and when the ventilator draws the oxygen in, it gets enriched oxygen. And if you have a pulse oximeter, you can monitor what the patient's getting. And in my experience, sometimes with 1 liter, 1.5 or 2 liters, you can adequately oxygenate a patient who's not critically oxygen dependent. The patient circuit is also very cleverly designed. It has a special connector to plug into the machine, which can only be placed in one position. It cannot be placed incorrectly. It's not possible to run this ventilator with the incorrectly placed sensor tubes and pressure tubes. The PEEP valve is at the end of the circuit and is easily controlled, and the machine tells you exactly how much PEEP is being delivered breath by breath. Additional items that you may need are a disc cable to get the oxygen from the pressure wall to the machine, a filter to protect the patient from the machine and circuit, and also to keep the machine clean. And we usually put the filter between the patient connection and the circuit. There is also a very beautifully designed soft case for which you can transport the machine, the front of the machine, the back of the machine. You can change the battery within the soft case, and the machine can easily be operated and carried with you or on your shoulder. I already explained to you that we always put the HME and antibacterial filter to protect the patient and ventilator, and we assemble the filter between the patient and the transducer or end expiratory port. And we use all kinds of filters, but it must be an HME and antibacterial. Thank you very much.